Okay, this is the first part of the class on circuit design. So we're gonna go through how to design circuits to comply with constraints. And not usually, actually always, we're designing a circuit that's based on one or more op amps. And the inputs are variables, and we cannot say if they are going to be positive or negative. Chances are they will be AC signals. They are never just like U or X or Y. They won't just be either +5 or +10 or something. It's just like a sinusoidal wave, or any wave, actually, we don't know. They are given in volts. And then the output, which is a function. So we're going to design a circuit that returns a function of those input variables. In this case, X, Y, Z, and U. And this is probably the simplest kind of function that we're going to have to design for, which is a sum of inverted signals, which points to, a summing amplifier. So this is typical for a single op amp that does summing, but I wanted to point out some other constraints in this video. So first, the function cannot go beyond 15 volts or below -10, which means the last op amp of our design, in this case is 1 op amp, will have these as power supply. VCC will be 15, minus VCC will be -10. And then we can use as many resistors as we want. However, we can only use multiples of 10. So it can only be 10, 100, 1K, 10K on 1M. So this is also typical if you're working with a circuit and you want to make something work and you only have so many resistors, that's all you can use. Or combinations of them. So let's get started. Maybe I can even zoom in here a little bit more. I don't know if you can see, but I copied the function here, and I already complied with use only one op amp. There's only one there. And I could also put the power there to get rid of this one. So if I put the 15 and the -10, I can just get rid of it right now. So here I'm gonna put 15 volts. Oh, I didn't change the color, huh? Unfortunately, I can't draw with my touchpad as well, but let's keep going here. So I am done with that second requirement. Now I need to do something about the multiplying by 0.01. 10, let's just start with 0.01, but keep in mind there will be more. So usually if you have pen and paper, you try to do this on paper first before actually doing all of it. So I'm gonna try possibly a 1K here, and I want to divide X by 100. This means I'm gonna put 100K here. I could have put 10K on the RF and 1 mega ohm on RI for X. So here, hopefully you see that as the circuit is right now this way. It's only f of x, and it's only minus 0.01x. So I haven't complied with the whole V out is the function of all of them. But you see that I put a ground on the positive input, on the non-inverting input, and I put X on the inverting input. That means it is inverting, and it's dividing by 100 because it's RF over RI. So far that's all I have. Oh, not minus, sorry. I have equals this way. Anyway, it's just temporary. So once we have this, let's go to the next slide and try to add Y. And I'm going to consider that we took care of this, even though now it's not drawn there, I'm sorry. And I'm going to consider that we did the 1K and the 100K. So I'm going to put a 1K here again. And I'm going to put a 100K here. I'm going to put a 100K on the X, but now for Y, it's 10 times Y. So now instead of 1K and 100, I'm gonna use here 100 ohms. maybe I can also add it here. So y is going to be multiplied by 10. So if I put 100 ohms here on y, now I have an f of x and y that is minus 0.01x minus 10y. I hope you can see that. And this is how I would go about grading you. I would look at what you have on this resistor, divided the RF resistor by the RI resistor, and then divide it, multiply by minus y, see that the power is connected, and that's it. So we keep going like this for Z and U, the same way. See, let me quickly, maybe, I'm not sure how quickly this is, but 100K, and then this guy here is 100 ohms. That's not very good, huh? Now for Z, it's the interesting part. Actually, let me just do U here. Let's do that one, because U needs to be multiplied by 5, but I have a 1K here. So really I want U, I want the F to be equals to minus 5U, but I already have 1K, so it's like this. I need minus 5U to be equals to, I need 5 to be equal to 1K divided by M. M is my thing, so M is the, M is, instead of M, I'm going to write RI. So RI is going to be 1K divided by 5, and therefore RI is 200 ohms, but I don't have 200 ohms here. So this means I need to use a second resistor here, and unfortunately I did not draw that in the right way. So it's going to be 100 in series with 100. If I were drawing, I would draw another resistor here in series with that. So this will be 2 resistors in series. For Z, the same thing will happen, except that this resistor here needs to be 1/3 of this, because I need to multiply by 3. In this way, and for this one here, I'm gonna have to draw 3 resistors in parallel. Of course, I can't even draw resistors in parallel, so maybe I will copy them. Anyway, I'm gonna write, just right now I'm just gonna write this. 3 1K ohm resistors in parallel. So this here would finally give me F equals to whatever I wanted there, actually, minus 10y minus 3z minus 5u. So hopefully you can use this method to figure out any function that has only negative coefficients, or terms that are negative. So I still need to put the power there. Hopefully you remember from my first slide that it was 15 and minus 10. And now we complied with all the requirements for the circuit design. So this is the design of this, a circuit that does evaluate this function here. Let me know if you have any questions. I hope this is easy to understand.